to Sequence and Series, and this is your Cloud Mentor Gavrish, and let's talk about the harmonic progression. A sequence is said to be a harmonic progression if reciprocal of terms of the sequence form an AP. That is, if A1, A2, A3, etc. An are said to be in the HP, that is harmonic progression, if 1 by A1, 1 by A2, 1 by A3, 1 etc. up to 1 by An are in AP. This will be forming HP, that is harmonic progression, only if 1 by A1, 1 by A2, 1 by A3, etc. up to 1 by An forms it is a reciprocal of that sequence forms the AP. Then it is said to be harmonic progression. And the nth term of harmonic progression beginning, that is Tn, will be from the beginning. Okay, the nth term of the HP from the beginning, that is Tn, will be equal to 1 by 1 by 1 by A1, 1 by A1 plus n minus 1 of 1 by A2 minus 1 by A1. Okay, and that's equal to A1 A2 divided by A2 plus n minus 1 of A1 minus A2. This is the equation for the nth term of a harmonic progression from the beginning. Okay, and nth term from the end, nth term from the end, that is Tn dash, will be equal to 1 by A1 An minus n minus 1 of 1 by A2 minus 1 by A1. Okay, that will be equal to A1 A2 An the whole divided by A1 A2 minus An of n minus 1 of A1 minus A2 of A1 minus A2. So that's the equation. And note that any one of the term of an SP cannot be 0, and nth term of an SP is the reciprocal of the nth term of the corresponding AP. Okay, and there is no formula for determining the sum of the harmonic progression sequence. And now let's look at the questions related to harmonic progression. And the first problem, if 20th term of an HP is 1 and 30th term is minus 1 by 17, then its largest term is, we have to find that is here it is said that the 20th term is 1. So that means according to the definitions, that is 1 by A plus 19D is equal to 1, right? This is a reciprocal. Harmonic progression is reciprocal of the arithmetic progression, so I can write like this, and that is equal to 1. And also we know that 1 by A plus 29D, that is 30th term. Okay, that is equal to minus 1 by 70, right? Yes. So that implies A plus 19D is equal to 1, that is 1 by 1. And also we can give it number 1, equation number 1, and A plus 29D which is equal to minus 70, right? Yes, minus 70, and give it the number 2. So on solving equation 1 and 2, we get A equal to 176 by 5 and D equal to minus 9 by 5. Okay, So now assume that its nth term is largest term. Okay, that's the question. So Tn equal to 1 by 176 by 5. That is this equation we have studied. That is 1 by a1, or the 1 by 1 by a1 plus n minus 1 of 1 by a2 minus 1 by 1 by a1. That is equation. So we are applying that here. So plus n minus 1 of minus 9 by 5. So we got 5 by 185 minus 9. Okay, and this term will be the largest if 185 minus 9 is least. Okay, the least positive integer value possible only for n is equal to 20, right? Yes, it is possible only for 20, and hence we can write tn equal to 5 by 185 minus 9n, that is equal to 5 by 185 minus 180, that is equal to 5 by 5, that is equal to 1. Okay, so the answer will be equal to 1. Answer is 1. So let's find it. Yes, it is here. Option C is the right answer. So let's move on to the next topic, that is the insertion of harmonic mean between two numbers. Let h1, h2, h3, etc. up to hn be the n harmonic means which are inserted between two numbers a and b, such that a, comma h1, h2, etc. up to hn and b, okay, form harmonic progression. Here total number of terms is n plus 2, and also 1 by a, 1 by h1, 1 by h2, 1 by h2, etc. up to 1 by hn, 1 by b are in ap. If this is in hp, then the other one is in ap, that is reciprocal. So, and let d be the common difference of this ap. Let d be the common difference of this ap, and therefore we get 1 by b will be equal to 1 by a plus n plus 2 minus 1 of d, n plus 2 minus 1 of d, and d equal to a minus b by n plus 1 of ab. Okay, n plus 1 of ab. And now e1, this 1 by h1 is equal to bn plus a by n plus 1 of ab, n plus 1 of ab, and 1 by hn and 1 by hn will be equal to 1 by a plus nd, 1 by a plus nd, and that's equal to 1 by a plus n of a minus b, n of a minus b all divided by n plus 1 of ab, n plus 1 of ab, and 1 by, that is 1 by hn equal to 1 by hn equal to a n plus b divided by n plus 1 of ab. So that's it. And if r equal to, this is a general form, and if the r equal to 1 and n equal to 1, then 1 by h1 is equal to 1 a of 1 plus b divided by 1 plus 1, 1 plus 1 of AB. So we got A plus B by 2AB, A plus B by 2AB, and that's the harmonic mean, and that is H1 equal to 2AB, 2AB by A plus B, 2AB by A plus B. So if we insert one harmonic mean between two numbers, then HM, that is harmonic mean, will be equal to 2AB by A plus B. 2AB by A plus B. That's it. And the harmonic mean of n positive numbers A1, A2, A3, etc. up to An is 1 by H equal to 1 by n of 1 by n of 1 by A1 plus etc. 1 by A2 plus 1 by A3 up to 1 by A. That's it. And if A, G, and H are arithmetic, geometric, and harmonic means between three given numbers A, B, and C, then equation having A, B, C as its roots is x cube minus 3ax square plus 3g cube by h x minus g cube, that is equal to 0. And now what is the relation among arithmetic mean and geometric mean? Okay, what is the relation between arithmetic mean and geometric mean? Relation between arithmetic mean and geometric mean. So that's it. And let A and B be two real positive and unequal numbers, and A, G, H are arithmetic, geometric, and harmonic mean respectively between them. And A equal to A plus B by 2, A plus B by 2, and we know G is equal to root of AB, and so now A minus G will be equal to A plus B by 2 minus root of AB, and that's equal to A plus B minus 2 root AB divided by 2. That I can write it as A root A minus root B the whole square, or root A minus root B the whole divided by root 2 the whole square. Okay, that's, and which is greater than 0, and because A and B are positive, so that means A minus G, is greater than 0. That means A is greater than G, that is arithmetic mean is greater than the geometric mean. Okay, that's it. And if A equal to B, that means the first numbers, that is A equal to B, then A is equal to G is equal to H. And if A is not equal to B, then A is greater than G, greater than harmonic mean. And now we know G square is equal to, this is the relation, G square equal to AH, D square is equal to A of H. Okay, that's it. And now the next problem is that I think I lost that problem. Yes, we got it. Let n element of natural numbers, n is greater than 25. Let A, G, H denote arithmetic mean, geometric mean, and harmonic mean respectively of 25 and n. the least value of n for which a, g, h element of the given set is which one. So here a is equal to 25 plus n, the whole divided by 2, and g is equal to root of ab, that is root of 25 of n, that is 5 root n, 5 root n, and h will be equal to ab 2ab by a plus b, that is 2 of a is 25, that is 50 n divided by 25 plus n. Okay, and a, g, h are natural numbers, so n must be an odd perfect square. N must be odd perfect square. So for n equal to, we have to apply 49, 81, 169 and 235 in the place of n. So we can if the a, g and h are natural numbers, if we give the any of these numbers, then that is the number we need. So 49, if we give that, it will not give a natural number in here and here, and 81 also doesn't gives, and 169 the same, but 225 gives the same for everything. That is arithmetic mean, geometric mean, harmonic mean will be natural number if we take the number n as 225. So the option D is the right answer. Yes. So now let's move to the next topic, that is the arithmetic-geometric progression. A sequence whose each term is obtained by multiplying corresponding terms of AP and GP is called an arithmetic-geometric progression. Yes, it is got by multiplying the corresponding terms of AP and GP. Okay, and it's called arithmetic-geometric progression. Okay, and if a plus d, a plus 2d, etc. up to a plus n minus 1 of d is an AP, and 1 r square, etc. up to r raised to n minus 1 GP, then on all multiplying corresponding terms of AP and GP, a progression is got, that is a of 1a and a plus d of r, a plus d of r, a plus 2d of r square, a plus 2d of r square, and etc. up to a plus n minus 1 of d of r raised to n minus 1 is formed, which is called the arithmetic or geometric progression. And the next topic is the sum of n terms of special series, that is n square and n cube. Generally, find the sum of n terms of any series. We can use the sigma before the nth term of the series, and the sum of n natural numbers, that is first one, sum of n natural numbers, sum of n natural numbers n natural numbers, that is equal to 1 plus 2 plus 3 plus etc. up to 4 up to n, that's equal to, we can write sigma n, which is equal to n of n plus 1 by 2, n of n plus 1 by 2. Okay, And now the sum of the squares of natural numbers, sum of squares, that is n square. Okay, that's equal to that is 1 square plus 2 square plus etc up to n square, which we can write sigma n square, which is equal to n of n plus 1 of 2n plus 1 divided by 6. And the sum of the cubes of natural numbers, or n cube, sum of n cube, which is equal to 1 cube plus 2 cube plus etc up to n cube, and that's equal to sigma n cube, which is equal to n square of n plus 1 the whole square divided by 4. Okay, otherwise we can write n of n plus 1 divided by 2 the whole square. Okay, that's it. Or simply it is sigma n the whole square. And that was it. So I'm ending this session.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.